Hello, I'm Jonathan Thompson. I am a product manager from Molex, and I'm here with Alan Hahn today to talk about a new kit for the FIRST Robotics design teams. Alan, how are you doing today?
Yeah, good to be here. So my name is Alan Hahn, and I have an electrical engineering background, and I was marketing co-lead for my FIRST Robotics team when I was in high school.
Thanks, Alan. Both me and Alan are both from Molex, and Molex is a manufacturer of connectors. We've been in the industry for over 80 years, and we build products that help to improve your everyday lives. Let's jump in and get started talking about the FIRST Robotics programs, the products that we work with to try to help students. So here at Molex, we wanted to find a way that we could make it easier for teams to use our connectors and build their robots, not only prototype, but learn more about how to use our connector systems and do it efficiently and faster. And so what we did was we talked to a lot of different teams out there, and we said, what are the challenges that you run into when trying to build cable assemblies? And what we were told is most teams are trying to use a hand tool to cut raw wire, crimp and poke those cable assemblies into the housings, and then it's still a connection system. And so we started talking to teams about what are the most common connectors they use, and one of them that they selected was the SL connector system, and that's the one that we decided to use for our kits that we offer. Alan, could you tell me a little bit about how, why it's so popular for teams to use the SL connector system?
So the SL connector system uses 2.54 millimeter pitch, and that complies with the FIRST Robotics guidelines. In addition, one of the more common gauges for the wires is 22 gauge, and it can go as small as 30 gauge. So this is one of those rare connector systems that has a very wide range of gauges. And when I say gauge, I'm talking about the American Wire Gauge Standard, AWG. We call it gauge for short in the industry.
Yeah, so why don't we talk about what do students get inside of the kit? What did we design to try to help it and make it simpler for them to use that connector system? So inside of the kit, Alan, do you got a kit?
I do have a kit.
Have you opened it yet?
Not yet.
All right, let's open it. It's like an unboxing video now.
Right. Let's see what we got here. So this is the cover. I see that there's a little QR code that tells me more information. And as I'm opening it, I see parts used to build the cables. I see the housings and the terminals and the wires all as separate parts. And then I see pre-crimped cables right here. Looks like I got a lot of goodies.
So what our goal was to try to make a flexible kit for students to be able to build as many different types of cable lengths, cable styles in a single kit. And so what Alan showed you was that there are connectors available, there are pre-crimped leads available, and then there are completed crimped cable assemblies inside of the kit. Each one should allow teams for up to 12 different cable assemblies and configurations, and that way they can prototype, breadboard, build a bunch of stuff, or use those on their final robot. So why don't we talk about what are the differences in the products that are inside the kit? Obviously, the connectors are the first ones that teams can cut and crimp cable assemblies. So if you wanted to make your own custom connector or custom cable assembly, we've got 6 connectors in there, both male and female, and terminals that are both male and female as well, for teams to be able to build completed cable assemblies and custom to custom lengths. Now they will need to have some raw wire and a hand tool to be able to crimp them, but we wanted to still offer that flexibility so that teams can build their own cable assemblies. Then we started putting in there pre-crimp leads, and we offer them for almost all of our connectors that are out there. And pre-crimp leads are very simple. They're a wire with a terminal that's been crimped by an automated crimp machine on a single wire. So there's no connector with it, it's just a terminal on a wire. So we call them pre-crimped because it's just a crimp, and customers are able to build and assemble, pin out cable assemblies however they want to pin them out. They're really valuable for teams because this way you can build up custom cables, you can cut them, and that way you don't have to try to fuss with the hand tool. Many teams have challenges when it comes to crimping cable assemblies because you've got to get a good crimp on the conductor and on the insulation crimp, or else the actual wire is going to have a hard time staying in there. And since these connectors are so small, it's really hard to crimp them, especially in the little tiny terminals of putting that wire together. So let's talk about the discrete cables. The discrete cables are completed cable assemblies with connectors on them. And so what we designed were cables that have common pinouts. Those are your white, your red, and your black cables, which are the most commonly used in FIRST Robotics designs, and they're completed cables. These cable assemblies have connectors on both ends, and they also have a label on them just in case you wanted to order additional ones. There's a part number right on the cable assembly for you to be able to order more cable assemblies. The nice part about these are they are fully crimped and manufactured in an automated assembly, and you know that the crimp is not going to be a failure point in your design. Having these completed cables are a great solution as you're building up prototyping because you know that's not a failure point. Now, they were designed to have male to female applications so you can use them in extensions, or if you don't need them on both sides, you could definitely cut one end and crimp on something else or use leaded wires if that's what you've got. Whether it's some of the devices we've seen out there have the terminal blocks that you just insert the raw wires, and that's another solution. So we really wanted it to be flexible. There's 4 different lengths of the pre-crimped leads as well as the discrete cables for students to be able to grab different lengths and use them in different applications. And it's really good early on in design to be able to prototype and see if your system works. So Alan, maybe you could help share some of the ways that teams would use these cable assemblies in their applications. Since you built as a team and you designed a robot in the past, how would a team use these cable assemblies in their applications?
So looking at these cable assemblies, I'm noticing that there are 4 and 3 circuit connectors, and that makes them suitable for a wide range of common protocols like I2C, PWM, SPI, which could be used for sensors or small motors, all sorts of things.
So Alan, these connectors are rated for up to 3 amps. Would they be used in power applications as well?
I'd say primarily signal. Power applications, I think we need to go to a thicker gauge. Another application I think these are good for is the robot light.
So that's right. We have one cable assembly in the kit that is designed specifically for the robot safety light. That cable assembly is a 36-inch cable where one side has a 2-pin connector and the other side just has blunt cut leads. And that's because on the robot safety light, there's a terminal block that teams can just plug in. So what we tried to offer was a solution that regardless of how long you need that cable assembly to be, teams can just cut and use that robot safety light and that cable assembly in their application. So Alan, outside of the main computer that they're hooking up to, what would the cable assemblies go to?
So teams may be using electronic speed controllers to drive their motors. You know, for those electronic speed controllers, you'll have your power cables that are actually driving the motor, but then you also need to kind of talk to that controller to tell it when to drive the motor. So that controller has maybe 3 or 4 diagnostic pins that you can plug these SL connectors into that then interface with your robo-reel. Something else you could be doing is, you know, as far as sensors go, because you need to know how your robot's oriented, sort of those sort of things. Gyroscopes, IMUs, other orientation type of sensors, they would all be using these SL connectors to interface with the robo-reel.
Hopefully this video helped you guys learn about how to use the products and the connectors from the SL connector system and the pre-crimp leads and discrete cables that are inside the box. If you'd like to learn more, there's QR codes all over the box that will bring you to a bunch of different pages on Molex.com, or you can just search FIRST Robotics on Molex.com to learn more and get links to the connectors. Thank you for your time and good luck this season with your robot.